Hello. In this screen recording, we're going to go through creation of a repository using the link that I provide for you guys for your assignments. And then we're also going to go through how we then bring the contents of this repository into RStudio, do some work in there, and then push our changes back to GitHub. So this is the link that you were provided. And what we're going to do first is go ahead and create the assignment. So I go ahead and say I accept the assignment. Which now makes a copy of the assignment that I had prepared, but then also tags on my GitHub username next to it and creates that repository for me. So this is a repository only I am able to see. It's a link created for me, and I actually have access to get contents from here and also push my changes back. We can see that the repository contains a variety of files. The most important one perhaps is the R Markdown file because that's where our analysis is. So when we're making tweaks to things, that's where we're going to be making the tweaks and then pushing things back out. But there are also a variety of output files. So there's an HTML output for you to that you can view in a browser, the results of your analysis, or there is a Markdown output, and that's actually easier to view on GitHub, so that's why we ask for that to be generated as well. And we'll go through some of the other files later. For the time being, let's get started here. So our next step is to get these contents into RStudio for us. So what I'm going to do first is log on to RStudio and then go back and grab the URL. I'm using the HTTPS here. Grab the URL of this repository. Go to RStudio. Say I want a new project. It's going to come from version control, from Git. I paste the URL. Just tab to get to the next field. And that automatically grabs the name of the repository and is going to make it the name of my project in RStudio. I could edit that, but I'm not going to touch it. And I want it as the subdirectory of my root directory. So that sounds good. Let's say create a project. At this point, it's going to ask me for a username. As well as my GitHub password. And voila, all the files are here for me to work with. Now, what we can see here is that here is our R Markdown file. And as we went through it in class today, this top part is the YAML, where I have some information, some metadata about my assignment. I have a title, I have an author name, so if you guys are working on your assignment, one of the first things you would do would be to replace my name with yours, adjust the date if necessary, and then go ahead and start doing the analysis. Let's see what things look like when we actually make a change here. I am going to change my last name just slightly, just so a change is recorded. And I'm going to knit the results as well, so that we can take a look to see what it looks like on the output side. We can see that the change has been instigated. And now what we can do is let's see what Git has been tracking. So I go to the Git tab here, and I can see that one of the files that was changed was the RMD file. So let's take a look at the diff. It shows me that the line shown in red was deleted and the line shown in green was added. So that indeed matches up with what we were expecting to see. And we can also see the same changes actually in these two files, the HTML, which is the resulting output. There's too much in there to show here, but also the Markdown file. So what I might want to do is I might say, since that one change actually resulted in all of these to change, I might potentially combine all of those changes into one commit and say I wanted to change my name. I commit. And then now that those changes have been locally committed, what we want to do is if we want to actually see these changes on the GitHub repository as well, I push. Now I'm interfacing with GitHub again. So that's going to ask me for my password. And indeed, things have been pushed. Let's confirm by going into my repository and just refreshing it. And I can see that the latest change came from me, and it is indeed the change that we made. And we can see that where the commit is being tracked, but we can also see that change in, for example, the output file. Say now I wanted to do something a little bit more exciting. So let's go through this Markdown document real quick. We talked about loading packages. We talked about loading data. Here we're loading the data set from a URL. And this data set is a CSV data set, so that's a comma separated values data. It's basically a spreadsheet. So we're loading it from a URL with the read_CSV function. And then what we want to do is, let's take a look at that data. I'm going to run these chunks and load the data. And I can see in my environment that the Gapminder data has been loaded. Each row is a country in a particular year. And for that country in that year, we have the life expectancy, the population, and the GDP per capita. And so also for each country, the continent is recorded, but obviously that doesn't change from year to year. So for every time we see Algeria, we're going to see that it's from Africa. And then we have the varying records for life expectancy, population, and GDP per capita for the years. The first exercise that we wanted to do was to subset our data sets so that instead of being data from all these years, so that's from 1952 to 2007, so that we only get data from 2007. So what we would want to do is we would want to say, I want to subset this data set. I want to put a filter on the year variable such that I only end up with the records where the year is equal to 2007. And I can do this using this structure. I start with my data set, and then I say, and then, this is the pipe operator. We'll talk about this more in class. And then we say filter where year is equal to 2007. And that should generate a new object that we're going to save as gap07. Then in the next step, we're using that new data set and we're plotting it where we place the GDP per capita on the x-axis and life expectancy on the y-axis, and we create a scatter plot. So each data point, each data observation is plotted using a point here. Again, I'm kind of brushing over the syntax, but we will talk more about the syntax and how to generate plots next week. I want you guys to get to a point where we can make small tweaks and change the analysis and push our changes. And lastly, we are to color the points by continent. So here in step 3, if we take a look at our plot, each country is represented here with a point. They're all in black, all in single color, so we don't have continent information here. But if we also wanted to get continent information, we could say now, instead of just using the x and y variables, also add a variable that dictates the color of the points, and that should be based on the continent. That's the only thing that we changed going from step 3 to step 4, and here is the resulting plot. We can see that majority of countries with low life expectancy and low GDP per capita are in Africa in terms of the continent, and we can see that Europe and the Americas are over here with higher life expectancies and higher GDP per capitas. So, what if you wanted to change your analysis? Let's take a look at how we might be able to change it so that we subset for 1952 only. So how would I subset for 1952? Earlier, I subsetted for 2007. So what I would do is I would say change this to 1952. I probably would want to change the name of this to gap52. And then what I would want to do is I would say take that new data set and plot it for me for the other plots that we're going to generate. So let's go ahead and knit this document, and let's see how we can very easily make tweaks to our analysis, because all of our steps were recorded. So the only change really in the code that I've done was for the year that I filtered, and then just to have an informative name, I changed the name of the data set and I updated that in my code in steps 3 and 4, where I'm using it to visualize things. You can see that the plots have changed, so we're definitely plotting a different data set here. So if that's it, that's all I needed to do, what I might want to do next is I might actually want to take a look at my diff just to make sure that I agree with all the changes that I've made. So the change is here from 2007 to 52, and similarly we changed the data set name in these two locations. And what I'm going to do is I'm actually going to bundle this commit for all of these files that were changed simply because of making that change. Remember, RMD file, R Markdown, is where is the source file. That's where we make changes. The HTML and MD files are for the output, and then these are the figures that are generated that are being included in our analysis. So you didn't have to generate these by hand every time you need they get generated for you, but it makes sense to bundle all of those changes into one, because the changes happened because of that year subsetting change that you've made. So an informative commit message here could be that change year of subset to 1952. We commit, we push, and now let's take a look at our Markdown file that we can view the results of on GitHub. We can see that the new commit is here, and we can see that the changes that we were seeing locally have all been reflected here. So I've walked you guys through creating a new repository based on an assignment link that you're given, getting the contents of that repository into RStudio, making changes in your analysis, and pushing your changes back to RStudio, back to GitHub.